morning, everyone. My name is Parth Pithani, and I'm your host for Robot Forward Warehousing Podcast. It has been a while that we did that, but I think it's peak season and Thanksgiving took us away. And I'm excited today to be joined by Anna Campaus from SimWell. I knew about SimWell, I would say, beginning of this year. Again, one of these stems from Modex Conversations, and I reached out to John at SimWell, and he introduced me to Anna when you talk about simulation and digital twins and warehousing. So I was like, yeah, I want to talk about it. It's a very interesting topic, and I think it's rightly time for to end this year with this topic as well as we go into 2025. And I reached out to Anna, and Anna was super nice. She's like, yeah, of course, let's talk about it. So I'm excited for her to join, and I'll let Anna do a quick intro on her side as well.
Sure. Some of my favorite topics: warehousing, simulation, digital twin. Hello, my name's Anna Camphouse. I am a team leader at SimWell, and my background is a lot of simulation. I've been doing that for over 10 years now. I've worked for large integrators, I've worked for manufacturers, and now I work at SimWell, which is a simulation consulting firm that also builds simulation, digital twin, different industrial applications, kind of anything you need, technology and analytics wise. We have somebody who can do it, and we can do it for you.
Awesome. Anna, you should tell me about that being a maths teacher. That is exciting.
That's true. I did actually start out as a little baby after undergrad as a teacher for quite a while. I was a high school math teacher, and that's actually how I found out about engineering, industrial engineering specifically. And once I found out what industrial engineering was, I thought, wow, this is the job I can actually do, where I just sit around and think about how to make things better and improve processes. That's what I should be doing. That's how my brain works.
Nice.
Time. So let's do that. So
That's
off to
exciting.
grad school I went.
That's always exciting. I was thinking on a side note, like if you know how to have patience with teenagers, I'm pretty sure you can have patience with
Oh
LD
yeah,
clients.
yeah. Even employees are it's easier than dealing with teenagers. So.
No, that was great. It's a great story. A great. This is one of those origin stories to learn about. So let's start with the basic. I'm new to this world. I'm sure many folks are. It's a topic that has getting a lot of traction. Just learning coming out of COVID and the disruptions and the adoption of different technologies. I'm sure that the big companies are already using this, and this is now getting mainstream, if you will. So help us understand, like if you want to explain the teenager or high schoolers, if you will, like the difference between simulation and digital twin. How should we be thinking about it?
Sure. So first, I think it's important to understand what simulation is. And the basics of simulation is it's a computer model of your system. And your system could be an entire warehouse, or your system could be like a sub area within the warehouse. You could be looking at just the docks. How do we optimize what's happening at our docks? How do we optimize how we're managing the yard and how we're bringing things to the door? Or, we just paid for a giant automated storage and retrieval system that needs to work together with our conveyance and our merges and our sorting. And like, how can we test that out to make sure it's actually going to give us the rates we're expecting? So the computer simulation gives you a chance to do that in faster than real time, which is important, and in a virtual environment. So you can do things that honestly wouldn't necessarily be possible in real life. So you can test out your what ifs, and you can do stuff much more cost effectively than if you were trying to like go on the floor and make those changes and just run it for a couple of days and see how it goes. That's much more costly than having a computer simulation.
Makes sense.
But now that we have digital twins, which I personally love, digital twin adds an additional layer to that. So a digital twin by itself is, and it's always going to depend on who you talk to, what the definition of that is. But I believe generally the accepted definition of that is it's a something connected to your real-time data. So in some cases that could be like dashboard are sometimes considered digital twins because they have that look at the real-time data. Sometimes it's a little bit more advanced than a dashboard, but the part that gets really exciting to me is when we do combine that real-time data with the simulation. So then we can take real-time data, feed it into a model, run what if scenarios on that. Here's the state of the system exactly right now. Let's predict what's going to happen in the future if we do X. But what also if we do Y, what's going to happen? You can run different scenarios and understand like what are the possibilities based on what's happening right now, or like what's the latest trend we're seeing in our equipment. This seems to be going slower, or what's another good example that you're going to see on the fly? Sometimes it's that the line slows down, or maybe a line shuts down, or something happens and you can't use a piece of equipment. All right, well, so what happens if we switch over to this older piece that maybe runs a little bit slower? How much longer will it take us to finish our schedule for today?
Gotcha.
Those kind of questions.
So that thank you for that introduction, and I think it makes sense to me. And to the way you mentioned about the difference between digital twin and simulation, I think it really differentiates and helps us understand. So thank you for that. That digital twin relies on the real time data. Within digital twin, and again, just maybe a tangential question here is like when you think about digital twin, we have all seen that NVIDIA video about like, hey, there is a aisle blocked and the forklift, automated forklift is moving. A camera sees that the aisle is blocked because there is some stuff. It tells the forklift to change the route. Is that a part of typical decision making process? Is anyone doing it, or is it still in like maybe 2-3 years away?
I mean, I can't speak for everybody because I haven't been in everybody's warehouse, but I haven't seen that in play myself.
Hmm.
I know it's certainly theoretically possible, and I think that's a great example of how you could use that kind of real-time information to make decisions.
Gotcha. Cool. No, that case has always been. I always thought that this is something that we can achieve, but I think to your point, like even within my conversations as well, I haven't seen that. I haven't seen the simulations yet, so I'm pretty sure digital twin and the decision based on digital twin is still in the future. But exciting. That's definitely exciting. So
Add
no,
a little
please
bit
go
more.
ahead, please.
I think the capability for having a full digital twin of your warehouse or manufacturing or any kind of facility really relies on like where the digital maturity level of the organization is, where they are within their digital transformation. Some companies, if you think of more recent companies, like an example that gets thrown around in the industrial Internet of Things space a lot is Tesla, because Tesla is a more recent company. They were able to build in this digital era from the ground up. So they have tons of information about everything that they're doing. But when you look at maybe a more traditional auto manufacturer, they were not building when it was all digital. They were doing things when it was very manual. So it requires a lot of converting to those digital systems to have that real time information. And warehousing is no different. There's a wide variety of what it means to have a warehouse out there. It could just be a building where you put your boxes and then somebody comes in and physically picks up the box and moves it, or it could be a building where you have a giant automated system that's moving things through, or automated vehicles that are picking things up. But there's always a wide variety, and generally the more human interaction that you're still requiring for one reason or another, the harder it is to digitize some of that stuff.
Makes sense. And actually, that's a very great example on why some companies are ahead because they were building during when technology was, I would not say easily available, it was available, not easily, but it was available, and they spend more dollars to get it, which is very interesting. That's true. I think that's what I've been seeing as with a lot of greenfield implementation as well. Like few companies who are for the warehousing. Well, Amazon throws around, Amazon warehouse is always thrown around a lot, and
That's
I think
another great example. Yeah,
yeah, and
Amazon.
yeah, so for us, like if we recently the news came out about the Louisiana warehouse that they started, I think Louisiana or they started a big, yeah, I think it was in Louisiana. They started a warehouse which was like robot forward warehouse with humans, and I'm pretty sure they have a solid simulation team that they might be using internally as well. That's exciting. No, that's awesome. So as we move from like, hey, this is simulation, this is digital twin. One thing I always think about is like, what does it mean that I'm doing a simulation? What is a systematic setup, if you will? Like, for example, and again, maybe let me just give an example so that helps us understand the question as well. Is like when I think about racking design, right? I know that I need to have a CAD designer, I need to have CAD, I need to understand the SKU profile, order profile, need to understand the SKU footprint to design a CAD drawing, which tells me is a double deep, single deep, or ASRS solution. Similarly, with when you think about, let's say I want to do a simulation for a greenfield warehouse, what is that journey to actually build that model?
So one of the first things I would ask you if I was doing a simulation for you is, what is your objective? What are you trying to get out of this? Because the advantage of simulation is that you do not have to build the entire warehouse in the infinite detail that exists there, and you actually don't gain a whole lot once you get past a certain point. The simulation can always be built faster if you are kind of condensing more of the information into it. So you don't want to necessarily include every detail. So understanding what you're trying to figure out helps me understand the level of detail that we would need. So once we understand that, the next thing to know is, all right, Here's the thing you're interested in finding out. Tell me about how the process is about around that work. So maybe we're interested in understanding what the layout should be. We're gonna do a common one I've seen is like it's not fancy, it's not automated, but it's like we have taped down spaces on the floor. Is this our best layout? Could we be doing something differently? So we'll divide everything by customer orders, or maybe we're dividing it by the day of the week things are going out. Is this the best way we should do it? So I would want to understand what's the process, you know. Obviously, in a warehouse, you're bringing stuff in, you might be storing it, you might be doing something to it. Maybe you're going to like put orders together and then it's going to leave. Tell me more about the exact steps that your people are following in that process so that I can understand what needs to be programmed in. Like it's those decision making points that are really the interesting part for the simulation because that's when things can change. And it's all about understanding how does this system change over time. Now, in addition to understanding the process, we'll probably ask you for some data. It's usually really helpful once we've been told, okay, this is how we do it, to take the data that comes out of the system, whether that's from SAP or maybe it's a Excel spreadsheet that your, building manager is using to say where everything's going to go, and just make sure that it matches historically, that it lines up and say, yes, I can see this truck arrived and then the material went over here based on the rules that you were given to me, and that matches with what we say. And the reason we would want to do that is because when the simulation's giving us information out, it's helpful if it looks the same as what you're used to. So we can say, okay, we made this change. Now when your things come into the building, we're going to move them to these other locations. And then here's the timestamp of when they could potentially leave. That's either sooner or later or the same as when it would have left previously. So it's all about understanding what's the process that's going on. What kind of data do you have to show us how that process has worked historically and the performance you've gotten out of it historically? It's nice to have a layout.
Yeah.
It's nice to know what it looks like if we don't get to go there in person. So sometimes when you're dealing with like a greenfield site, it doesn't actually exist yet, right? There's no place to visit. So kind of walking through the CAD drawing or even a sketch to understand what they have in mind for how it's going to be laid out.
Makes sense. Gotcha. And then pretty much you would just go ahead and develop that in some kind of, I would say, a modeling tool or a software tool.
Yeah, there's a lot of different tools, and it's not like give us information, we go away, and then come back when we're done. It's usually a back and forth of, hey, we did this. What do you think? We did that. What do you think? So
Gotcha.
our focus is more of an agile simulation development, which is a little bit different than traditional simulation development, which was more of the give me your information, let me go away and do my
Gotcha.
work and come back to you, because we want to make sure we're showing it along the way so that we don't veer completely out from what you had in mind, which is
Makes
kind of the risk when you go away and don't talk to the stakeholder that you're making the model for. The other thing is sometimes the burning question you have when you first start a simulation might change, because depending on the size, it can take anywhere from like 2 weeks to 6 months to develop, and the level of detail and everything.
Wow. Nice. Wow. And from the objective purposes, is it like just help me understand the object? Usually, hey, I want to push out more volume through this space, or I'm seeing this bottleneck with conveyors not always in line. Like, what are the different objectives that people come to you about?
Oh man, there's lots of different things. Sometimes it's how can we get more performance out of this building? A lot of times, like kind of adjacent to that is like, hey, we built this facility as a cross-docking facility, but now we're not really doing cross-docking anymore. How should we manage this a little bit differently? Like we can test out, what are the physical changes? Like I'm going to bring in X equipment. I'm going to bring in this automated storage and retrieval, but you can also test out what we call like operational policies. So now I want to have 6 people on first shift and 7 people on second shift and 3 people on third shift. Are we going to be able to get the volume through? Or, man, let me pull up my list. I have like a list of all sorts of applications.
No, and this is actually a very good example. Like, I actually like what you said about like, hey, I'm at 5, 6, and 3 warehouse associates, and my labor force is only this much. What are the metrics, like labor planning? Basically, you're helping them do labor planning around it. And traditionally, I can tell you, as of today, most of the things are done Excel based.
Right.
There is a static about like, hey, my one associate can do, let's say, 60 units per hour or 60 orders per hour. That's my static number. So I'll be using it to ship out my volume. And that's very
That's
interesting.
useful, but it's like, what if you could combine that with, here's the schedule here's everything I know that's coming at me today. How's that going to play out? That's a really common use for once a simulation's been built and it's, answered maybe the initial question that you wanted to answer, how should we lay this out? Or what happens when we have this layout? How does that perform? In a lot of instances, it can be turned into an operational tool and handed over to the ops folks to be like, oh man, like 6 people called off today. What are we going to do? Should I try and call people in? Should I just, try and grin and bear it? Or maybe we'll just shorten our breaks and do whatever like they can test out different scenarios themselves. So
So, so,
that's one of
so
my favorite things to do.
oh,
So
that's
they
actually
live on.
exciting. Yeah, I was about to say that actually. I never thought about that. I thought it was like you do the exercise, you give them the output, and you go away, and the model goes away with you. But it
You
feels like you,
can, but you don't have to. That's
yeah,
what's
that is true.
exciting.
Yeah, yeah. Because now it just unlocks a huge potential, right? Because as an operator, I'm only relying on my Excels, but I can now actually have a tool like what SimWell might be providing right now, where I can literally go and like just use that tool every day to do my planning. Oh, that's awesome. That's awesome because I never, yeah, that never clicked. That's awesome. So they have something. So they would basically, and just again, just paint a picture. You don't have to go into details, but like I would say, an operator will have access to some kind of digital or a digital model of their existing warehouse, which they
Yep.
can play around. Okay.
Yeah, and we have a UI that's set up for them to run it and say, okay, this is how many trucks are coming in, or if you have a schedule that's coming through. I always use SAP because a lot of people have SAP, but whatever your WMS is, if you have the schedule that's coming at you for the day, typically we would, because a lot of most, I would say all simulations are pretty custom. There's a lot of reusable pieces from project to project, but it's always based on that particular instance. So it's built to accept that particular data, your particular schedule data, and then
Makes sense.
feed that in pretty.
Oh, that's definitely exciting. I think I'm like very much excited about this space because I was always thinking like a one and done kind of deal. I never thought of using as a tool, which is unlocked for me today. So thank you for that.
Yeah, no, that's what I mean when I say we also do like industrial applications where you might start with a simulation for one purpose. Maybe you're doing a CapEx, you're going to spend some money on equipment, but then we want to have this live on once we have the equipment in the building. How can we help manage it? So,
And you answer my next five questions, if you will. So appreciate that. And again, I think as we talk about the benefits of it, the different objectives, and how the setup happens, I think if you have to walk me through one of the case studies, again, I don't want to. I'm not looking for the names or anything like that, but just help me understand a customer pain point that the customer came with a problem, and how did you guys solve about it, and what was the outcome?
so one that comes to mind for that is it was for a manufacturer, and this was kind of related to what I mentioned earlier with the cross-docking warehouse. They had a large warehouse they had originally set up for cross-docking, and they wanted to only use it for that. Well, in reality, sometimes that doesn't happen, and the nature of the business had changed in the few years since they had opened that and done their last like reorganization inside the warehouse. And so they came to us and they're like, all right, what should we do here? So they had previously been organizing all their products coming in by day of the week that it was going to go out, which was fine because nothing was supposed to stay there more than maybe a few days. The way that their suppliers changed what they were doing and the way that their own manufacturing changed what they were doing meant that now they were holding things sometimes for weeks. And so when you, obviously, I probably don't have to tell you, but when you're holding stuff for that amount of time, if it's all kind of jumbled together, you end up with damage, you end up losing things. So it was a question of, we know there's a better way. We used to do this a different way. Now we want to separate by customer order, but how large of a space should we dedicate to each customer order? We have a limited warehouse space. What should that even look like? Um, I thought this was an interesting problem because they did have a lot of data where they could say, here's the nature of the product that was coming through over the last 6 months. Let's look at what it was. We can look at all of our customer orders and understand, all right, before here's how it accumulated in the space. So it comes in, we got one thing from one manufacturing plant, we got 6 things from another manufacturing plant. How does what we have on the floor change over the amount of time that it's sitting there? And then the other important question in that is how much of that order arrives before we need to ship it out, and then how much of it's going to arrive once we've staged it to leave, so that we don't have to have 100% of the order on the floor. And to me, this was an interesting problem because it was a highly variable product. It was very customized. It ranged in size from little bitty keys to giant filing cabinets to really heavy glass walls,
Hmm.
and all of that could be going on in a customer order, and we had to figure out how to categorize it and put it into these spaces. At the end of the day, we were able to test that with a variety of different sizes for their layout, and it was a very simple, just like tape on the floor kind of layouts. But what are the dimensions of those? Should we have some small ones and some large ones? Should we have all medium sized? So we ran a couple of different experiments with different sizes and seeing how they would accumulate over time, and we were able to recommend a specific layout for them that
Oh,
they
that's awesome.
changed everything to. And I think it was like, I think the savings was like a $500,000 a year
Oh, wow, that's awesome.
perpetual from doing that. So
Wow, that's
that's
awesome.
really nice.
You help them save money, and at the same time you also help them use the existing space for a different business purpose. So that's a solid win for there, huh? Very interesting. I'm just thinking about like that has so much potential in warehousing world now, because I feel like I was recently talking to a customer, and what they have is something very similar. The business is changing. They used to do a lot of buy and hold scenarios, so they had a lot of inventory depth, and now their business is changing, so they are going on more. They don't need to hold that much inventory, so their racking system, which was like 10 deep pallet racks, pallet. So now they need to go and change it to like something else,
Yeah.
which is selective VNA right now. And that's the same similar problem that I'm trying to solve for them. But it's just exciting to see how as we new buildings are gonna be less, and this real estate is getting expensive anyway. So how to reoptimize the existing real estate using some kind of tool which actually tells us that yes, I think it is possible if you do this way instead of just Excel. And I started my world in Excel. I feel like Excel is good, but it's very easy to fat finger it and just the output comes something different.
The thing with Excel is well, I love Excel also. I still use Excel daily, if not hourly on things sometimes, but it doesn't necessarily give you the view of the change over time, which is really what simulation does. It allows you to play out a scenario beyond like a one glimpse. So it's what happens as we go through a couple of weeks, what happens as we go through a couple of months.
That
Or if
is
you're
true.
talking like supply chain level, what happens if we're going through like a year or two?
That is true.
What's what's happening here?
And also it doesn't have the visual element that a lot of simulation tool
That's
have,
true.
because seeing is believing kind of thing, right? And it helps you
Yeah.
solve for it. Like at least from my side of the world, I feel like when I show someone that, hey, this is what your rack looks like and this is what your forklift would do the stuff, I think instantly I can connect and they can see their building. They can start visualizing their building with that racks and those kind of solutions. So it really helps them. Like I think it makes a sales cycle a little shorter.
Yeah. No, having the animation with the simulation is huge. Like, simulation has been around for a really long time, like a really long time before computers were capable of doing that. But now, with the computing power we have, even from when I started my career to now, the graphics that we can do are amazing.
That's
And you don't
awesome.
need those on every project, but like you said, it helps people really understand what they're getting. Sometimes we're meeting people after they've gone through a sales cycle with the integrator and they're like, okay, here's our plan. Like, what do you guys think? Is this going to do what we want? And then we are building it in 3 dimensions. And they're like, I see. We need to move. That IO can't actually be there. That needs to move.
Oh,
Or
interesting.
like those are much taller than we thought. Do we have the right fire suppression that we know we're going to need in this building, or
Wow,
something like
that's
that?
awesome. And that is end user coming to you when they had this design, then end user comes to you all and they're like, hey guys, let's validate this design if it's really worth $200 million investment or $300 million investment kind of thing. Oh, wow. Awesome. That's interesting.
And it also helps them build their operational policies ahead of time. I've seen that a lot too, where you might have the greenfield site, but you don't, in a large company, you don't always have the people to sit there and think through, okay, how are we going to run this in the day to day? And so sitting with them and saying, what does it look like when people go off shift? Or is there going to be overlap? Or is there going to be dead time in the warehouse? Like, we're just going to cease all operations for that time. What does that look like? Oh, you have robot wrappers and you're going to share them around. All right, well, how do you get them from place to place? And what are the rules of once it starts wrapping in a particular load? Does it finish the whole load, or are people allowed to take it somewhere else and redirect its work?
I have so many questions here right now because, as you mentioned about, so one of the thing with what I have seen is like in Excel, typically you make assumptions that okay, my ASRS will do 300 bins per hour, my unit sorter will do 600 units per hour, and use those numbers and try to just create one-time static view of what the building will look like. With simulation, we can have an ongoing view of like if what happens around it. But is it fair to assume that during the simulation exercise, you all or anyone who is doing the simulation exercise will have to still depend on the OEM to provide you the like their throughputs?
It depends. I mean, yes, you're going to need to know what that system's capable of. Do you need all of the, like, how many miles per hour their lift can go or how fast they can go down the aisle? Maybe not. It depends on how tight that system is. Especially with automated storage and retrieval systems, what I've seen is that the robot or the crane or whatever it is that's doing the work to get the item, that tends to become your bottleneck, depending
Yeah,
on the system.
yeah,
It's either that or it's the whatever you have taking it away from the system out
yeah,
front. So if you get into a situation where that coordination between what's taking it away from the system and then how it's whatever robot or crane is pulling it out of the system, if they're not working super great
yeah.
in harmony, then you start getting into the nitty gritty of like, well, is that, is that accelerating at 5 meters per second squared or not? Whatever the
Makes
issue
sense.
is. But it helps to have general guidelines of like, we're expecting it to take this long to go all the way to the end of the system versus pulling something from the front of the system.
Yeah, mini loads or yeah, cranes, as you mentioned. Yeah, they are single point of failure, right? If there's something happens to that, all the inventory is stacked up and you can't do really anything around that. But if it's a shuttle system, you probably have one shuttle come over longer time. And I think that's one of the thing that I remember studying a case study about Walmart doing using. I'm pretty sure you might be aware of it, like AnyLogic, to do the simulation for ASRS system that they had. It's on YouTube that I was watching as I was preparing for this conversation. They did a simulation with them to really figure out that hey, what if out of 20 shuttles, 2 shuttles go down? What is our throughput changes then? Because that's something that you can't really control. It's hard to see on an Excel file because it's very dynamic changes that happen. They were trying to create around it. They had all the variables onto it, and then they came out with a solution that really worked for them.
I think the other thing to think about with a shuttle system too, and even with the mini load is like, where do you have your SKUs in the racking too? Are you completely, if one of those shuttles goes down, were you storing all your SKUs of one type on that particular level? Now you can get none of them. So the SKU slotting is always interesting to look at too with those systems.
Yeah, that is true. That is true. That is
That's
bane of
another thing you can look at with
yeah,
simulators.
bane of industrial engineers, right? The field industrial engineers. Slotting is something that keeps them busy every day, pretty much. Good, that's good because the operators are relying on experts to help them out, which is always good. I think this has been a great conversation, Anna. I have a couple of more questions before I let you go, but so I want to talk to you about like so this is great, right? Simulation. What is simulation? How to set up the system around it, the case studies, and the how to win the business around it, or how to solve the business problems. One of the things that I wanted to understand, as you've been in industry for a while, what are the common challenges that you might have encountered for someone who is new in this journey, or someone who doesn't know about this journey as well?
I think the biggest challenge is usually data availability. So what kind of data do you have at your fingertips? And sometimes it's more than you think. Even it might seem like, oh, we just have this spreadsheet. Well, there's probably a lot of information in that spreadsheet. You also probably have a lot of information from people who've been in the business a long time. It's interviewing those people when you're doing a project is always enlightening. Every time I talk to someone who works on the floor, I learn something new about the system that I didn't hear from the managers that I was meeting with previously, right? Because they live and breathe what's going on. I think making sure that you're data focused is going to be really important going forward in the future because data is going to be what sets every business apart. What data you have, what you're able to do with your data, and then if you put that into practice, what you've learned from it.
Yeah. That's a very good actually challenge, and I think it's funny that you mentioned that, because the same challenge that I see in like non-simulation world, that hey, if I ask for some data, it's always going to be a challenge. That I don't know where to get that data. I don't know how to get that data. The guy who knows how is he doesn't work in this time zone, and he doesn't have the bandwidth to pull me the data and stuff like that. So I think it's funny that I mentioned like that has to be a solution, but then I look about it, there is no solutions out there, because probably because their data is so proprietary for all of them, it's not easy to be easily accessible. So it's a unique challenge.
Yeah, there's a lot of custom WMS software out there too, which doesn't make matters any easier. I mean, the good thing is, like, I feel that a lot of people coming out of school now are very data literate and very computer science literate in a way that they weren't always. So if you're like, oh, we need to do a SQL query, they're like, okay, well, let me just look up how to do that. I'll do it. It's not quite as intimidating as it maybe once was.
Yeah, that is true. ChatGPT has made the life easy for
Yeah.
people.
I was gonna say one of the things I think about is sometimes you just get like word blurbs from people where like it's not numbers per se, it's like a statement about something, and the large language processing that is there's now the capability of, I think is going to be really helpful in the future because now we can take that information that's really more about, it's more anecdotal at this point and look for patterns within that in a way that we haven't been able to before.
and
To me, that's far, far future, but maybe I'm wrong.
no, I use my LLMs in my daily life, and I can say that like a lot of times, if I want to have like a thought exercise with them, or like, hey, let's debate. I have this idea, and you be the opposite. Let's debate and let's figure out what happened, because it really helps you have a perspective. Which, and again, it has benefits for sure. I think overall, again, I'm not trying to be a vocal house for them, but I think that's benefit. And this has been a great conversation. Last, as we wrap up, any advice for the audience, listeners, as they think about this simulation journey?
I'd say don't hesitate to ask if something can be simulated. I mean, if you want to reach out to me on LinkedIn and run your idea by me, please do. I have I mean, I work for a simulation consulting company, but at the same time, I like to live right between IT and operations to try and help everybody get information they need. And there's quite a few times people have come to me with projects and I'll be like, that's probably not a simulation, but you could do this other thing. So
It's awesome.
it's not a one size fits all tool. And neither is digital twin, but it's one of those things that's going to help every business really move to the next level as you become capable of doing those.
Makes sense. And I agree. I think it's a great tool. And as I said, I'm personally a fan of it. Great conversations, great insights. And I'm pretty sure as the way I felt my mind opened up, the listeners are going to be feeling the same. So I appreciate your time.
Thanks. So happy to talk to you.
You have been listening to Robot Forward Warehousing Podcast with Parth Pithani. Stay connected with us by subscribing to the show on your favorite podcast player. If you like what you heard, please rate us and help us reach more warehouse robotics practitioners. Thank you for listening. Until next time.